Let us discuss this problem of electrostatics and as well as electricity and current. It is useful for JEE Advanced. इसमें दिया क्या है? There are four identical conducting plates marked as 1, 2, 3, 4. Plate 1 and 4 carry initial charges plus Q0 and minus Q0. प्लेट 2 एंड प्लेट 3 कैरी नो चार्ज, इन पर कोई चार्ज नहीं है. बट अच्छा, सेपरेशन बिटवीन 2 and 3 is d and separation between 1 and 4 is 2d, right? They are placed symmetrically. Plates are placed symmetrically. We can say that this is d by 2, this is d by 2. What we have to find? We have to find the heat that will be dissipated in a resistor which is connected now between 2 and 3, plates 2 and 3. It is to be noted that initially these plates have no charge. So this can be done by two methods. One method I am going to explain, that is more fundamental. And what we should realize, why there will be why there will be dissipation of heat. Heat will be dissipated if there is some current here. Why current will come? It can come if there is potential difference. There is potential difference because these two charges will produce certain electric field here, and that field we know that field will be Q naught upon A epsilon naught. But we already know if we have equal and opposite charges on parallel plates, then field between the plates is Q upon A epsilon naught, right? There is already some field here, and that field will be producing potential difference. Due to that potential difference, the current will start. But as the current starts, charge will start flowing from this plate to this plate. Though this plate has zero charge, this plate had zero charge. So if up to certain time charge small q has flown from 2 to 3, then at that instant, say plate 3 will have charge small q and plate 2 will have charge minus q, right? Because this is neutral initially. If small q has flown from here to here, then obviously this one third will have q charge, the second one will have minus q. And this flow will tend to reduce potential difference. Why? Because these two charges will have their own field, and that field will oppose the original field. It can be easily realized. So at any instant, net potential difference we can write, then we can write the instantaneous current as V by R, and the potential difference will be obtained by field into distance. We know that if there is somewhere field D in distance D, then in this distance potential difference will be E into D. So first we write here field at that instant when there is plus small q and here is minus small q, and these two charge will be intact because they are not connected to any area. The net field now between the plates 2 and 3 will be this much field. We know that equal and opposite charges on parallel plates produce field how much? Q upon A epsilon naught. So there will be two set of pair of opposite charges. So net field will be this much by same formula. These two will produce field in left and these two will produce here field in right. The net field is this much, and into D कर देंगे तो we will get potential difference V. Let us give a symbol for simplifying the calculation. Epsilon naught A by D as C naught. We will use the symbol, a symbol of capacitance, because it is dimensionally a capacitor. So D will be equal to Q naught is minus small q upon C naught, and I at the instant will be equal to V by R by Ohm's law, And I is nothing but rate of flow of charge. The rate of flow of charge means rate of dq by, that means dq by dt is I. So I is dq by dt and I is b by r. So we can write dq by dt as b upon r. And we can now सिंप्लीफाई बाई इंटीग्रेशन डी क्यू के नीचे ये वाला एक्सप्रेशन लाएंगे जहाँ स्मॉल क्यू है बिकॉज दैट वी कैन विल इंटीग्रेट. So from here we will do integration, and integration will be done. I think I should change the variable here because we are not doing up to infinity directly. We are doing integration from time 0 to t. The small q is initially 0. At time t this is small q, right? So this integration will lead to this one equation. This is not difficult to realize. First it will be in the log, then take anti-log, we will get this expression, right? And again if we differentiate it with dq by dt, we will get I will be this much. So we have obtained equation of current as function of time, expression of current as a function of time, and heat now can be easily obtained by using this relation. I square r will be instantaneous power in time dt. This much heat will be dissipated. So we can integrate it up to 0 to infinity. Why up to infinity? Because at infinity current will become 0. You place infinity here, it will be 0, right? And if you integrate it, we will get this expression. This is not difficult to integrate. I am omitting that step. And C naught can be replaced as epsilon t by t. The same expression can be obtained by the concept of energy of a capacitor, because initially here will be an effective capacitor of capacitance epsilon naught a by 2d. And this capacitor has charge q naught. So we have initially energy q naught square upon 2 cc is epsilon naught a by 2d, right? This is the initial capacitance. And after these two plates are shorted, effective separation between these plates will reduce by distance d. So final capacitance will be how much? Epsilon naught a by simply d. These two distances will add up to give net effective separation between these plates, because these plates are now shorted, so there will be no electric field here finally. So they will not contribute in potential difference, right? So as if these plates are not there, तो न्यू एनर्जी विल बी q नॉट स्क्वायर अपॉन 2, और यहाँ नया कैपेसिटेंस आ जाएगा, न्यू कैपेसिटेंस, दैट इज एप्सिलॉन नॉट ए बाई सिंपली डी. दिस इज द न्यू एनर्जी स्टोर्ड. This is final energy stored, you can say, and initial energy was how much? Q naught square upon 2 epsilon naught a upon 2d. 2d was here. So we can see initial energy was more, final energy is lesser. If we subtract this final energy minus initial energy, we can get the loss, and you can easily see this will come out to be the same as, right? So this is a simple but good problem for JEE Advanced.